Station. This is Arne, Duncan, and students from Parkland Middle School and Washington Math, Science, and Technology Public Charter School at the United States Department of Education, Washington, D.C. How do you hear us?
Secretary Duncan, good afternoon. This is the International Space Station and the crew of Expedition 21. We are reading you 5 by 5.
I hope that means well. Thanks so much. This is an absolute thrill for us, and we have a number of students here ready to ask questions. Thanks for taking the time. This is actually a chance of a lifetime for us, and I'd like to introduce...
Okay, well, it's a thrill for us as well to be with you, and we are ready for the questions from the students.
Hi, Jeff. This is Kristen. How does pushing the boundaries of our capacity in space result in terrestrial benefits, and what are some examples?
Well, I think you can find some very obvious examples from history. The history of humankind is the history of exploration. If you look at the explorers of old that searched and discovered the Western Hemisphere in North America, and then spread out and also searched the oceans around the world, all of that and others that followed, the Lewis and Clark expedition, the exploration in science and engineering, all of that has resulted in much that are beneficial for our living now, much of which we take for granted. So I think this is just the current chapter of human exploration, and it will ultimately benefit humankind in many different ways.
Okay, thank you.
Hey Jeff, this is Jeremy. Since acceleration due to gravity becomes smaller with an increase in altitude and with a decrease in latitude, how has NASA applied this knowledge to strategizing launches of spacecraft into space?
Well, Jeremy, that's a very good question. There's that and a lot more details that we have to consider when we launch spacecraft into orbit, and also when we operate in orbit, when we rendezvous and dock with spacecraft that are in orbit. For example, the Space Shuttle or the Soyuz dock into the space station. And those details that you talked about, as well as many other details, have to be accounted for. Fortunately, the properties and characteristics that you mentioned, as well as many others, can be predicted through mathematical modeling. And I know you're getting introduced to mathematics and a little bit of science and engineering now, even now, and you'll get more in the future. And you'll find that you can model much of the phenomenon that we observe in the universe around us, and which makes it very predictable and enables us to do things like what we're doing right now, flying in orbit, where we know precisely where we are and where we will be at any point in the future.
Hi, Nicole. This is Diamond. Is there proof that there is water on Mars?
Okay, and I believe the question is there a proof that there's water on Mars? And I am certainly no expert on this, but past missions as well as current missions that are ongoing have certainly given us evidence that there is water on Mars. And I would like to think that as part of our overall plan, we'll continue towards the exploration of Mars, and someday with humans setting foot on Mars, and maybe one of you guys in that room will be the ones that will be able to tell us in person whether there is water on Mars.
Привет, Макс, это Александр. Какие спортивные упражнения вы делаете и как часто?
Thank you very much for this question. Мои любимые упражнения, я думаю, сейчас стали здесь на станции, это бегать на беговой дорожке.
To jog on the new treadmill on board the station.
На американской стороне новый тренажер, силовой тренажер.
And there is a new exercise device on the American segment. It's called iRed. It's a wonderful exercise device. We are very thankful to the engineers for the creation of this machine, and with the help of this device, we're able to keep in shape. So this has become our favorite exercise. Thank you.
Bob, this is Kate. Pourquoi c'est important pour vous d'avoir des astronautes de différentes nationalités qui travaillent ensemble?
Les habilités, les capacités d'un équipage dans l'espace sont mieux quand les membres individuels représentent les différents points de vue, les différentes expériences. C'est plus facile de résoudre des problèmes orbitaux. D'une perspective mondiale, je crois que si nous sommes capables d'opérer dans l'espace, de faire la recherche ensemble par un équipage international, nous sommes aussi capables de résoudre les problèmes comme l'environnement et la santé aux terres. I think it's easier for a crew to function well, and we have more abilities when each individual member brings a different experience or different point of view. And if we can do this on orbit, why can't we do it on Earth as well to try to attack some of the significant world problems like health problems and environmental problems as international members?
Hi, Frank. This is Andrew. Welsh rover uitdoen mag ze voor en omvloog.
Andrew, danke schön für Ihre Frage. Ich spreche nicht sehr gut Deutsch. Ich bin Flemish, so ich spreche Flemish. That's why I will answer your question in English. We prepared for this mission about 3 to 4 years. The training consists of a number of aspects. One aspect is theoretical training, where you learn all the systems that are on board of the International Space Station here. There is practical training, where you learn to work with the different equipments, how to do water sampling, for example, how to perform certain experiments. There is also physical training because, as Max explained, we need to do a lot of sport here on orbit, and we also need to prepare for doing that on the ground. And last but not least, we are also subjects for medical experiments, and so a lot of our time as well on the ground goes to what we call baseline data collection. It's where medical people and scientists measure our performance on the ground, and then they also measure it in flight and after the flight, and then they compare this data to try to understand how our body functions here on orbit. So in total, this took about 3 to 4 years for me.
Hi, Nicole. This is Lauren. Most space missions appear to be male-dominated. What is being done by NASA to select more females and inspire young girls to consider careers in astrophysics or astronautics?
Well, yes, I think especially when you look at a crew like this, it might appear that that the programs are male-dominated, but there's more to what's going on here than the spaceflight missions themselves on orbit. If you look at the ratios of women to men in mission control and on all of the ground teams, I think you'll find that women are very well represented. And actually, when you look at the ratio that's here, we're well represented as well, because it pretty much maps to the numbers that are in the astronaut office itself, as well as what you will probably see traditionally in university makeups. But I know, and I'm very thankful, that NASA is doing many things. There's many outreach programs at the middle school as well as the high school and university levels that are encouraging young women to get into science and engineering. And I know I experienced that myself through my education when I was studying aeronautical engineering. And fortunately, I was very close to the Kennedy Space Center and was able to see a lot of the work that went on there. So I think we should be encouraged by the numbers that we're seeing. I think that very positive action is being taken to make sure that women are represented in all of the programs that we have.
How you doing, Jeff? This is Archie. What steps are being taken to minimize health risks such as decompression sickness, radiation exposure, and loss of bone and muscle?
Well, let's see. I'll take radiation first. We have specialist scientists on the ground that predict the radiation levels and make sure that we don't exceed certain threats on the ground that predict the radiation levels and make sure that we don't exceed certain threats on the ground that predict the radiation levels and make sure that we don't exceed certain threats on the ground.
And they should be back pretty soon. This is the communications dropout everybody was talking about. This is in Houston, and it's the Space Station Control Center. We have one that looks similar to this at the Johnson Space Center in Houston, and it's where they control the shuttle. So we actually, I was telling Secretary Duncan, there are control centers around the world for each of the space agencies. We work through Moscow for the Russian part of missions. We work through Tokyo, Japan. Outside of Tokyo, a place called Scuba. That's where the Japanese Space Agency runs theirs. The European Space Agency is in Germany. Yes. Is that right? Bonn? Okay. And as we bring more partners on, then we'll find that there will be other places around the world. As we bring commercial partners in fact, if we are working an experiment for a commercial partner right now, we may be talking to somebody on a university campus. So because of the magic of communications and satellites and the like, people don't have to now go to Houston.
And Department of Education, do you have us back? We had a satellite handover in our communication system.
Hi, Bob.
I don't know if you caught the answer, Mike. Okay, you did catch the answer. I'll pass it on to Bob. Go ahead with your question.
Comment est-ce que vous communiquez avec vos familles?
Vivre à bord de la station pendant 6 mois, c'est long et c'est dur sans famille. Mais à bord de la station, nous avons des systèmes de communication comme le courrier électronique et aussi un téléphone. Et chaque jour, nous communiquons avec nos familles. Et chaque semaine, nous avons l'occasion de parler par conférence de vidéo avec nos familles. Mais nous avons hâte de rester au terre avec nos familles après cette mission. It's long time to live aboard the space station, 6 months without our families here, but we do have email, we have telephones, and we have a weekly video conference to help us keep in touch with our families. And when the shuttle visits, we also get care packages that includes sweets and magazines from our families. It's very nice.
Здравствуйте. Будучи исследователем, использующим Международную космическую станцию сегодня, как вы бы посоветовали изменить или улучшить станцию?
Will utilize your experience on the International Space Station. What will be your advice to them to make it safer and more efficient?
Спасибо за вопрос.
Thank you for your question.
Во-первых, необходимо всем
First of all,
полететь в космос очень хорошо готовиться на Земле.
Who want to go to space have to prepare well on the ground and be ready for everything.
Большой любимый дом. Тогда будет
And the station should be treated as your house. The same way you treat your house, and then it will be safe and in perfect order.
Nicole, this is Michael. How does water technology for life in space relate to providing cleaner water on Earth?
Thanks for the question. I think that's a really interesting thing that's going on right now, and not only with respect to water, but with respect to energy in general. We are self-sustaining up here with our solar power, and we are recycling our urine and other fluids up here to provide clean water. And these same things that are going on up here on the space station have direct application to improving lives for people on Earth. In fact, there are many NASA engineers right now that work on these same systems that are on the space station, that work for organizations like Engineers Without Borders and others that are going off and taking some of this same technology into regions where people are struggling for clean water. So it's really exciting, I think, to know that these things are going on and to be able to take what's going on in space and apply it to improving life on Earth.
Oh, this is Lloyd. My question is, what physiological changes does your body experience as a result of being weightless, and how does it relate to your physical fitness?
Well, I think the main thing that we see up here is a loss of bone and muscle mass, and that can happen fairly quickly. So we, on the ground, spend a lot of time maintaining good fitness levels. We try to stay in shape as best as possible, going to the gym and working out both aerobically and with resistive exercise devices. And then once we get up here, like Jeff mentioned earlier, we spend about 2 hours a day working out. We have the equipment that Max mentioned, both 2 treadmills, bicycle, and a really nice resistive exercise device. And we do a lot to make sure that we maintain or at least minimize the bone and muscle loss that we have.
Hi, Frank. This is Carmi. I was wondering, of all the jobs you could have decided from, why did you choose to pursue being an astronaut?
Well, first of all, I don't know if I had so many jobs to decide from, but of course there were certainly a few. First of all, when I was young, I was fascinated by space. It was just the time that they were starting to talk about black holes, supernovas, the Big Bang, how the universe was formed, and I was really fascinated by that. But on the other hand, I was also fascinated by engineering and by flying. And so that's why I decided to become a pilot, a military pilot, and also an engineer at the same time. And this kind of set me up for my future career in space. And I really enjoy still to fly. It's wonderful to fly here in space, but I also really enjoy to do engineering tasks and to work with the scientists. And for me, it's kind of an ideal combination of things that I like. So I'm very lucky together with, I think, all my crewmates here. We are all very lucky because we all do something that we really, really like.
Bob, this is David. In what direction do you think the Canadian Space Agency will go next?
Hi, David. Canada is a country that thinks that involvement in exploration and innovation is very important. So undoubtedly, we will be involved in the next international effort to venture out further into the solar system. I don't think Canada on its own will decide what the next destination is, but as a member of a group of countries, I think we'll come to a consensus as to where we should go next. I'm not sure what that will be. The moon is likely, perhaps an asteroid, perhaps a Lagrangian point, perhaps Mars. Wherever we go, I think we just need to go. It's important to explore and innovate.
Hi, this is Arne Duncan again. I just want to thank you for your time. This has just been a remarkable experience, and we can all live a little bit vicariously through you. It's a fascinating glimpse into your life. The students asked, I thought, very thoughtful questions. You guys gave great answers. So thank you so much. This is an experience we'll never forget, and we wish you continued success. Good luck now.
And Secretary Duncan, thank you very much for joining us today. It was really our pleasure, and thanks as well for all the attention that you give to science and technology and engineering and space also in education. We think it's really important, and space can really inspire young people to go for scientific and engineering careers, and that's really the future, and we need to continue to build on that. We also have a little tradition here on the International Space Station. Every Friday evening we call down the birthdays of all the people that support us during the week or during our training, during our spaceflight itself. And we also happen to know that tomorrow it's your birthday, so we will break the tradition for once, and we will not call down the birthday on a Friday evening, but we will do it right now. So, Mr. Secretary, happy birthday, one day in advance.
Happy birthday!